So again, this is the intro into limits. So the whole chapter is wrapped around limits, but this is the intro in it, okay? And the limit, it sounds like this daunting thing, but it's actually quite simple. The limit is like what happens at the graph at that point. So we're going to learn a couple strategies to find the limits of things. Part by like algebraically, part looking at a graph, part learning how to use a graph and a t-chart, that kind of stuff. So we start with just the definition. If f of x becomes arbitrarily close to a unique number L, so L can represent any number, as x approaches C from either side, then the limit of f of x as x approaches L is written as that little box. So this is read as the limit as x approaches, the little arrow is read as approaches of value. That value could actually stay as C, and we'll talk about that towards the end, but it also could be a value as in a single number like 0 or 1, or it could be infinity, negative infinity. So it's asking you what's happening to this function as that x is approaching that value. And the limit is literally, usually, the easiest way to think about it is, what would happen if I took that value and I plugged it in? If there's a variable there, I would plug it in. If there's not a variable, if that was just like a single number, 3, think about what the graph of y equals 3 looks like. What does it look like? It's a horizontal line. So what's going to be true about all the values of y in the graph of f of x equals 3? They would all be 3. So if it's just a constant, then literally the limit is, no matter what it's approaching, right, left, and the end, negative infinity, positive infinity, a value, it would always be that value, okay? And then if it has a variable, then we change it. So we start with a t-chart, okay? This says use the table to estimate the limit. Now notice these are not your typical values. We're starting with something like 1.9, okay? And then going to 1.99 and 1.999. The middle value should match the value on the limit. So this is saying what is the limit as x approaches 2 of this function. So we're going to literally take and plug these values in. I'm going to plug in 3. I'm going to do 3 times 1.9 minus 1. I'm going to do 3 times 1.99 minus 1. I'm going to do 3 times 1.999 minus 1. I'll start there. 3, 1.9 minus 1, and I get 4.7. 3 times 1.99 minus 1, and I get 4.97. 3 times 1.999 minus 1, and I get 4.997. When I plug in 2, I get 5. When I plug in 2.11, so I'm just going to keep going. 3 times 2.001 minus 1. 3 times 2.01 minus 1. And 3 times 2.1 minus 1. This is 5.003. 3 times 2.01 minus 1. 5.03. 3 times 2.1 minus 1. 5.3. So this time we built our own table. Sometimes they'll give you the full already filled out table. But then you want to, again, pay attention to what you're looking for. The limit as x approaches 2. Where is 2 on this t-chart? In the middle. So as I am coming at 2, there's 2 directions. I'm either approaching 2 from the left, which means smaller than 2 coming up to 2. Or I'm approaching it 2 from the right, which is bigger than 2, coming back down to 2. In both directions, as I go towards that middle value, what value is it? 5. 5 is the limit of the graph as x approaches 2. Now it says use a graph to confirm the answer. So if I were to physically graph this function, y would equal 3x minus 1. What kind of graph is this?
Linear?
A line. Yeah, it's a line, right? Because it's raised to the first power. How do I graph a line? Start at -1 and then use my slope, which is 3 over 1. Up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1. Or reverse it, down 3 to the left 1. You can go in either direction. Draw your line. Now the goal of this is to see what happens to my function, which is the graph, as x approaches what value? Nope. As x approaches 2. So 2, where my x is 2, would be in a line with here. As it approaches 2 from the left, what's my y value? 5. As it approaches from the right, what's the y value? 5. So it confirms that your limit is 5. Now the notation on that, like you're going to eventually see, it'll say something like limit as x approaches 2 with a little minus. And that means as x approaches 2 from the left. And then the other side would limit x approaches 2 with a little plus after it. And that means limit as x approaches 2 from the right. Yes. Yeah, we'll talk about what happens when it is. Questions so far? Yeah. If you have your graphing utility, I'm actually going to teach you a trick on your functions to help you with stuff like this. This is not required, but this would certainly help with time. So the first thing I'm going to do is I'm actually going to use my y equals to help me find those values. So I'm going to go to the y equals function on the calculator, and I'm going to type in my equation. It doesn't matter. As long as you don't hit sine or cosine, tangent, any of the trig functions, it doesn't matter what mode you're in. Oh, sorry, I guess it does, yes, because we want a y equals, so we want to be in function. But it doesn't matter if it's radians or degrees, if that's what you're asking. So I go to my y equals and I type in 3x minus 1. All right, so yes, everybody got it typed in? Yes. Okay, now I'm going to go back to my home screen, whatever, hit second quick, get back to your regular screen. And then if I want to know what the value is, if I plug in, let's say I'm going to go from left to right on my t-chart, so 1.9, then I can call back up the equation that's in my y1 spot there's a couple different ways to do this, but the fastest is doing alpha trace. And a little box pops up that looks like that. Alpha trace is what I hit, and it pops up this little box. And it's referring to all the y's that are in there. So if you have multiple equations in there, you can do this with any of them. We only have y1, so I'm going to hit enter on y1. And then I'm going to open my parentheses. You have to do the parentheses, otherwise it tries to multiply it times the value. So open the parentheses, type in what I'm plugging in. So I'm going to do 1.9. You don't have to close your parentheses at the end. You can just hit enter, or you can close your parentheses. But if I hit enter, it's going to give me the value of that function at 1.9. If I do the same thing, alpha trace, I can go back to y1 and I can type in 1.99. There's 4.97. I could do alpha trace, grab y1, and I can do 1.999. I can do alpha trace y1, 2. Alpha trace y1, 2.001. Alpha trace y1, 2.01, and alpha trace y1, 2.1. You could also go to the graph and hit your value. Again, there's a bunch of different ways to do that. But that's an easy way to plug in a bunch of points, okay? And if you have your graphing utility, might as well use it. Questions on that process?
And we'll have it for the quiz.
If it's a question like this, you would have it for the quiz. I haven't even begun to build your quiz. I assume I will give you part and part, just because there's so many that could be that way. If I want to see this from my graph, obviously I could go to the graph. Oh gosh knows what my window is. Let's say I'm going to adjust my window. -10, 10, oops. -10, 10. And if I look at my graph and I want to see where my x is 2, I could go to trace. I could look until my x approaches 2, and I could see that as x approaches 2, my y value is getting closer and closer to that 5. It goes from 4.9 and then it jumps it at 5.7. I could go to second trace, and go to value and say what happens when x is 2, and it will bring me right to 5. So there's a bunch of different ways to do this, but if you're filling your t-chart, I would recommend that first method. If you just want to find what happens at that exact point, then I would go to the value. Questions? Okay. That's one way to find the limit, is literally a t-chart with the values smaller than where I want to look leading up to it. So like a 0.9, a 0.99, and a 0.999 are pretty common. And then the values after it, like a 0.001, 0.01, and 0.1. There are times, like Kevin had just asked, is there ever a time in which your values are going to be different? And the answer is yes. And when that happens, the limit, it fails to exist. So if you've ever seen, what's the movie? Oh my gosh, where she talks about Lindsay Lohan, Mean Girls, and she's like, the limit does not exist, right? It's actually a legitimate thing, okay? The limit does not exist if one of these three cases happens, okay? One is it approaches a different number from the right side and the left side. So if I was looking at a graph and it was something like a piecewise function, so if I had a piecewise function that looked like, let's say this, as I'm coming from the left, my coordinate point is approaching this y, and as I'm coming from the right, the coordinate point is approaching that y. Those are two different values. So if it's two different values, we say the limit does not exist, okay? The second is if it increases or decreases without bound as it approaches C. So this would be something like a rational function. If I had a vertical asymptote and my graph was going to positive infinity or to negative infinity, they could both be positive, they could both be negative, one could be positive, one could be negative, it doesn't matter. But if it increases or decreases without bound, as let's say this is 2, I would say the limit as x approaches 2 does not exist, okay? And the third is if it oscillates between two fixed values as x approaches. So if you, again, have two different values and it oscillates, meaning you'll see a graph that almost does this. Like as you're getting closer, it goes up and down and up and down and up and down like that. Like sine really squished together, okay? We would say it does not exist because it keeps changing too fast in between that small space, okay? That's what it means by oscillates between the two values. So if you had those three, you would simply say it does not exist. And in the homework, you'll see it'll say like find the limit. And if it does not, say it's DNE does not exist. Okay. All right, example 2 says show that the limit does not exist, then use the graphing utility to verify. So we're actually going to graph it first. Okay. So, and then we'll actually flip this, and then we'll talk about how that happens. So I want you to first graph this function. I want you to graph y equals absolute value of x over x. So when I go to my y equals, we don't have absolute value bars on our calculator. You have to go to math and scroll over to NUM for number. So it looks like this. So I'm going to go to y equals. I click on math, I scroll over to NUM, and I grab ABS, that's absolute value, okay? And then I put x in there, and then I can divide it by x, or I could have set it up as a fraction, either way. I'm gonna hit graph. And it's a piecewise function. If it is less than 0, then my y is at -1, and if it's greater than 0, my y is at +1, okay? So what this would be does not exist, and the scenario would be that as it approaches 0, it has two different values. You with me? Yes? Okay, so the other way we're going to learn how to find these limits is to plug values in. What would happen if I plug 0 into this function? What happens if I plug 0 in there?
You get like a plus or minus 1.
If I plug 0 in, I get 0 over 0. What happens when I divide by 0? Undefined. Is undefined. So that is algebraically how you would know it doesn't exist. Okay? So from visually, I have two different y values. So this does not exist. Yep.
But then when you get that like little plus or minus above like the 0, like that.
The absolute value? That just means it's going to be positive. Positive 0 is still 0. So it'd still be undefined. Is that what you mean?
Like, because you know how you said like later on we're going to get like...
The plus or minus here, you mean?
Yeah.
So that would be different. That could say, as you're coming from the left, what is it? That would exist. As it's coming from the right, good question, it would exist. But if it doesn't, you have to go from both sides. Okay, so then the next one is the limit as 1 over x minus 1. Do you remember what this looks like? Do you remember rational functions? It's been so very long since we did rational functions. Do you remember how to find these suckers? You have to worry about your vertical asymptotes, your horizontal asymptotes, and all that good stuff. Sound familiar now? What is a vertical asymptote on this equation? 1. So there's a vertical asymptote at 1. How about a horizontal asymptote? You remember how to find those? It's determined by the exponents on the top and the bottom, right? What's the exponent on my numerator? Is there a variable there? So if there was an x there, what would be the exponent on it? 0. And in the bottom, it's 1. And if the numerator is less than the denominator, then your horizontal asymptote is at y equals 0. And then your function, and honestly, it doesn't matter for the rest of this problem, but your function will either go top right, bottom left, or it will go bottom right, top left. But it doesn't matter because the point of this is what? It doesn't exist because it increases or decreases without bound as it approaches 1. Okay? So the reason here is because it would increase or decrease without bound. If you had taken 1 and plugged it in, I end up with 1 over 0 again. And that's the other way that I can determine it doesn't exist. So there's 2 parts there. Does it exist? Yes or no? And then if it's a no, why? Is when you would need to look at the graph. So if I plot that on my calculator, y would equal 1 over x minus 1. And then if I graph it, so based on the graphing utility, there's the graph. This is my 1. And because it approaches 1 unbounded, on the right-hand side it's going to positive infinity, on the left-hand side it's going to negative infinity, it would not exist. Yep. You just make whatever it is positive. You mean on the calculator? Hit math, and then scroll over 1 to NUM. And it's ABS. It's the first thing. Questions on those? All right. So now, what if you're already given the graph? These hopefully should be easy. You're already given the graph, and it says use the graph to find the limit. Where are we looking for the graph at? Where it goes to what? Where it goes to 1. So I'm trying to find what happens to my x value, or to my y values, as my x approaches 1. So I go to the graph. This would be where x is 1. Here's the coordinate point on my graph. And what value is there? 2. That's it. If I took and plugged it in, if I had the equation 1 minus 1 squared plus 2 is 0 squared plus 2, which is 2. So these should match, okay? I would say if you're given the graph, you may not be given the equation. And if you're given the equation, you may not be given the graph. So make sure you know how to do it both ways. Easy stuff, yes?
How could you tell from the graph that it's
2? You just have to find the point where x is 1. So x is 1 here. And then this is 1, 2. So you're looking for the y. It's the y value, because that's what f of x is, right? F of x is the y. So it's the y value when x is 1. Questions? All right, now you're given a graph and an equation again. Use the graph to find the limit. As we are approaching what value this time? -3, so this is -1, -2, here's -3. What's true about my y values? Doesn't exist because one's increasing without bound and one is decreasing without bound. So if either of those happen, it doesn't exist. Easy stuff? Yes? Okay. Understanding. Yes, okay. All right, now we're going to do the direct substitution. So we talked about this a little bit. We already even did one. All you have to do is literally plug x in to your value, okay? So whatever the x approaches on the bottom, you are plugging in. And then here's what you need to pay attention to, is there are times that if you plug it in, it may appear to be undefined. So if I plug it in and I get a 0 in the bottom, it appears as though it's undefined. But you have to be careful because you might be able to have simplified that expression first, and then it would exist. So we're going to first look if I can factor or simplify, check that first, and then plug your value in. All right, example 5. A says, as x approaches -1, find the limit of x to the third minus 3x plus 7x. So first of all, can I simplify that to cancel anything out? No, there's not anything even in my denominator. That's the first thing you want to check. So I'm literally going to plug them in. So -1 to the third plus 3 times -1 plus 7. What's -1 to the third? -1. 3 times -1.
Wait, isn't
That's
it?
a negative.
This is negative. Sorry, -3 times -1. Positive 3. Good. And then plus 7. So I'd get 2 plus 7, which is 9. Go to the next one. Now our trig back. The limit as x approaches pi of tan of x. So I'm going to take that pi, I'm going to plug it in, and I get tan of pi. What is the tangent at pi? 0, right? Pi's on the left-hand side. -1, 0, 0 over -1 would be 0. And C brings back in your ln's. The limit as x approaches e of 6 ln of x. I'm going to take the e, plug it in, I get 6 ln e. ln of e cancels, right? Whether this was the exponent, because you could have done that too, you could have brought 6 to the exponent on the e. Whether we cancel it here and grab the exponent, or we cancel it here and grab the numerator, the coefficient. Same answer, which is 6. Still good? Yeah. Mm-hmm. Continue. All right, the property of limits. Okay, here's some things we can do with limits. Now, I would say if we have values in the place of these values, I just plug in. Like, I don't worry about using my properties to simplify and then plug in. And I'll show you what I mean in a second. But there are going to be times in which you are given something that literally looks like this. Like it says x approaches c, and we don't have a value for c, so I can't just plug it in, okay? And that's when we're going to apply these properties. So if I had an f of x to begin with, if it told me f of x, well, I don't know why I rewrote it. It's here. If it told me f of x was L, and then I took my function, and those are not absolute value bars, those are brackets, and it said find the limit of b times f of x, then all you have to do is b times L. So whatever that original value is, it's a scalar multiple, you multiply it by. If it asks you to find the limit of two functions added or subtracted from each other, then you literally take their two limits and you add them or subtract them depending on what it says. So if it said the limit as x approaches c, and up here I got f of x was 4 and g of x was 7, and I wanted f of x minus g of x. All I do is take the limit of f of x, which would be 4, and subtract from it the limit of g of x, which would have been 7. So you literally just replace those values and do as it says, pretty much. Then you actually get the product of the two. So if it said the limit of f of x times g of x, then I would take the limit of f of x, whatever value that is, and multiply it times the limit of g of x, whatever that value is. If it's division, f over g, then we put the limit of the f over the limit of the g. There will usually be a restriction there, like whatever's in the bottom can't be equal to 0. And then the last one is if we raise it to a power, then you literally just take the limit and raise it to that same power. And they will look like this. All right, give this information to evaluate the limit. So f of x is 5 and g of x is 7 as x approaches c. So A says -3 f of x. What would that answer be? -3 times 5, which is negative 15. The limit of as x approaches c, f of x plus g of x would be what? 12. 5 plus 7, which is 12. And the limit of as x approaches c of g of x over 4 times f of x. So what's g of x? 7. And then in the denominator would be 4 times what? 5. And I get 7 over 20. That's it. Questions? Yeah. You're waiting on Sam. Any questions on what we talked about today?